We're going to talk for a moment about verifying an algebraic identity or disproving that same identity. So this is going to be a huge part of pre-calculus when we get to trig in a little bit, but for right now, we can actually practice this same sort of idea right here, but we're going to do it through examples and counterexamples. And so what this means, first of all, to know what an identity is, it's just a statement of equality. We're saying that x plus 3 squared is x squared plus 9. Well, what you're going to notice in a moment is that these aren't necessarily true. That's why we have to verify them. So check this out. If we say that x plus 3 squared is the same as x squared plus 9, we're basically saying that I can take anything, a, plus anything, b, squared, and that would be the same as that first thing squared, a squared, plus that second thing squared, b squared. So the question is that actually true? And we can do this by picking any two random numbers, plugging them in, and seeing if that actually holds. So the number I'm going to pick for a is I'm going to say that a is equal to 2. And the number I'm going to pick for b is I'm going to say that b is equal to 3. So that means that 2 plus 3 squared would have to be equal to 2 squared plus 3 squared. So in this situation, 2 plus 3 is 5. 5 squared is 25. And this would be 2 squared is 4, plus 3 squared is 9. 25 and 13. Like, obviously 25 does not equal 13, so we have actually taken this abstract example, a plus b squared equals a squared plus b squared. We have given it an actual real number equivalent to check and see, like, is this actually something we can do? And we've learned that in math, we cannot say that the square of a binomial is the same as the sum of those two separate squares. This is not a property that we can use. The same thing is going to happen over here. Check this out. We've got the square root of some number of squares. It's like the square root of a squared, where a is 5, minus the square root of b squared, where b is x. And we're saying that that's the same as a minus b. Okay, so if that's the case, then what we're saying is that you can just sort of like split up a square root, and you can take the square root of the first term, square root of 25 is 5, and the square root of the second term, square root of x is x squared is x, and it should work out. Well, if we pick two numbers and see if this works, we're going to see something a little bit different. Let's go with, actually 25 is a great, let's use 5 for a, why not? In this case, oh, I used 3 for b, just like this. Anyway, this is boring, I'm getting silly. If we pick 5 for a, we need another number for b. I'm going to go with 3. So that means that, in this case, 5 squared minus 3 squared should be equal to 5 minus 3. The idea is I can take the square root of this difference, and it should come out the same. This becomes the square root of 25 minus 9, and this becomes 5 minus 3 is 2. Okay, 25 minus 9 is 16, which is 4, and that super does not equal 2. Okay, so once again, we've disproven this identity. Tune into the next video for how to prove an identity.